Okay, so up until now, we've been looking at two-dimensional coordinate systems. In other words, for example, this door, this is a plane. And in the past, we've had an x-coordinate, which is horizontal. We've had a y-coordinate, which is vertical. Well, now we're extending this into 3 dimensions. So we're going to have a 3-dimensional Cartesian coordinate system. Now, typically, what we have is, we have the y-axis, not the x-axis, but the y-axis that is a horizontal axis. The z-axis is a vertical axis. And then, coming out of the wall, right here, going in this direction, this is the positive x-axis. Okay, so again, y is going horizontally. The positive y-axis goes this way. The z-axis, the positive z-axis is pointed up, and the positive x-axis is coming out of the wall and going in that direction. Okay, so the first thing is, this plane right here, this 2-dimensional plane, the door, this is the YZ plane right here. Now, the x-axis, we're going to assume x is 0 is right here. Right here, this will be x equals 0. So in this plane, the YZ plane, the equation of a YZ plane is x equals 0. Now, suppose I come out 1 unit, okay, in the x direction. Now, this yellow paper represents a plane, where x, I've now moved 1 unit in the x direction. So this piece of paper represents the plane x equals 1. Now suppose from x equals 0, I move only in the x direction 5 units. So now, if I move 5 units, this plane is still parallel to the YZ plane. This plane would now have an equation x equals 5. Okay, now let's look at this wall right here. Okay, now what do we have? We have an x direction, and up and down we have a z direction, right? But the y is not changing here. Okay, the y is horizontal. So here, x is changing, and the z, the vertical part, is changing. So this wall right here is the xz plane. And what is y? Well, it's not changing. It's y equals 0. Now suppose I have a plane parallel to this xz plane. And suppose I move out 4 units in the y direction. Now, this yellow piece of paper, it's parallel to the xz plane. But what is the y value? It's fixed. I said I'm moving 4 units out. So this would be y equals 4. Now, let's look at the floor. Okay, so the floor down here. Okay, I'm moving in the y direction, horizontally, and this way, coming out of the wall, the x direction. So the floor down here, x and y, they are changing. So that would be z equals 0. Now suppose, so this is the xy plane, z equals 0. Suppose I move up 5 units in the z direction. That's what the yellow piece of paper represents. So instead of z equals 0, I'm still parallel to the xy plane. So this would be the plane z equals 5. All right. Suppose I am on the y-axis right here. So on the y-axis, y is changing. But x is always 0 on the y-axis, and z is always 0 on the y-axis. So here we have, instead of an ordered pair, we have an ordered triplet, x, comma, y, comma, z. So for example, right here, suppose I'm 10 units out in the positive direction, but I'm on the y-axis. So the coordinate of that point would be 0. Remember, on the y-axis, x and z are fixed at 0. So this would be 0. Again, if I'm 10 units out, 0, 10, 0. Suppose I'm on the z-axis. Well, y is 0 and x is 0. So on the z-axis, suppose I'm going up 20 units right here. And this is the z-axis. So my coordinate would be 0 for x, comma, 0 for y, comma, 20 for z. And now, suppose I'm on the x-axis. On the x-axis, the y is 0, the z is 0. They're fixed all along the x-axis. So for example, here, a point here, let's say I'm moving out 20 units in the x direction. So the coordinates here would be 20, comma, 0, comma, 0. Okay, now, we're going to be looking also at planes during the semester that are not parallel to the YZ plane, or the XZ plane, or the XY plane. So for example, you could have planes that look like this. All right, a few more examples. Suppose I have a point where my finger is, and suppose the coordinates of this point are 1, comma, 2, comma, 3. And I say to myself, how many units away from the YZ plane am I? Well, the shortest distance, you drop a perpendicular. So again, my coordinates are 1, comma, 2, comma, 3. So if I want to now find the shortest distance to the YZ plane, if I drop a perpendicular, I'm moving in the x direction. How many units? Well, x is 1 here. So 1 unit. Now, suppose I still have the same point, 1, comma, 2, comma, 3. And I want to know, what is the distance to here, the XZ plane? Well, I drop a perpendicular. Look, I'm moving in the Y direction. How many units? Well, if I'm at 1, comma, 2, comma, 3, I'm moving 2 units to get to the XZ plane. So the distance from this point to the XZ plane is 2 units.